A box with a rectangular base is to be constructed such that the perimeter of the base of the box is to be 50 inches. The height of the box must be 12 inches. Part A. Find the dimensions that maximize the volume of the box. Part B. What is the maximum volume? In this problem, we are trying to maximize volume. So we're going to definitely need the volume of a box formula. And the volume of a box formula is right here, where it's V equals length times width times height. Now in this problem, we know what height is. So what we have to do is we have to find out how we're going to come up with only one missing variable, because we don't want two missing variables like the L and the W. So what we're going to do is we're going to use the fact that perimeter is equal to 2W plus 2L, which in the problem they said had to be 50 inches. And we'll use that equation to solve for width so that we can write width in terms of length and get down to one variable. So we take this equation and we solve for W, which will give us 25 minus L is equal to W. So my width I can rewrite now as 25 minus L. So in my volume formula, I'm going to have volume is equal to my length times my new width, which is 25 minus L, times my height. Now if I simplify this, I get the quadratic equation where volume is equal to negative 12L squared plus 300L. So here's my equation that gives me a parabola if I were to graph it, and I can use that fact to find the vertex of this parabola and find which dimensions are going to maximize my volume. So if I use negative b over 2a to find this length that will maximize my volume, I have negative 300 over 2 times negative 12. And if I simplify that, I get 12.5. And that, remember, is my length, because this is my x-coordinate or my L-coordinate of my parabola if I were to graph this. So if my length is 12.5, right here, length is equal to 12.5 inches, then my width will be 25 minus my L, or 12.5 inches. So the length and width that will maximize the volume is 12.5 inches for both the length and the width. Part B now asks, calculate this maximum volume. So right here we did the length of 12.5 times the width of 12.5 times the height of 12, and that's going to come out to be 1,875 cubic inches.